Before I get started with the presentation itself, let me just show you one thing here, which should be quite interesting. It is the price development of Ethereum, which is a cryptocurrency that sits on the, or Ether is really the name, and it sits on the Ethereum network. And one of the interesting things, and I'm sure most of you will have followed this over the last few days, maybe weeks, is that it only took off really March this year, and then it had another bump in May, and then it started really taking off around about the 19th of May with a slight dip, probably people realizing, and then going up all the way till it's now leveled out at roughly $300, 282, but right now, but it's roughly 300, and the trend is still upwards. So there's definitely serious movement in the market. There's definitely lots of stuff happening, and happy to take some questions about it at the end, what we think the root causes are for these events. But for now, let's focus on the basics. And I call it blockchain for dummies because I like these yellow black books quite a bit, because I'm not a technical person. I am just a business person. So we're going to do a quick introduction to begin with, and then we're going to talk a little bit about what blockchain is not. Then we're going to talk a bit about what the blockchain is. We're going to talk a few use cases. We're going to highlight some that make sense. We're going to touch on the topic of cryptocurrencies. Then we're going to talk about some of the companies and names you probably have heard and what they mean and who they are and what stands behind them. We're going to take a quick peek into the future, and then we're going to open it up for questions. So just 2 words on Fintricity and myself. We are an agile digital transformation consulting firm, and we have clients such as Danone in France, or Santander in Spain, Santander in Portugal, HSBC over here, and a few others, mainly in the financial services space, but not exclusively. I've also chaired last week a conference around big data monetization and telecoms, and that's pretty much the areas that we cover. It's big data and analytics, it's anything disruptive such as blockchain or distributed ledgers, and then lastly change management. So these are my areas, and I'm typically the one speaking on various events and presenting ideas. So let's get started with the topic itself. And I'd like to clear out a few confusions. So what blockchain is not Bitcoin, and Bitcoin is not a blockchain. Blockchain isn't regulated at all. It is not particularly easy to understand, same as SQL is not easy to understand, or any other database standard isn't easy to understand. And it is not implicitly business case driven. Now, what is it? Well, first of all, it is a chain, and a chain is sitting on a distributed ledger. So a ledger, as you know it, is just the standard information around who owes what and who is owed by whom, and that is set up in a distributed fashion. It is resilient and secure via keys. You can't change it. It's immutable. That's one of the underlying big things, that it's hashed and therefore then immutable. And it has special nodes such as miners. These nodes are computers. Nodes are CPUs basically, and they operate as miners, or they operate as others. So these contributors all hold the ledger. And then it is a whole range of design and development tools and applications that sit on top of the chain. So what is the chain? And to make it easier, I tried to visualize something that actually not myself, but a fellow friend used to teach his 10-year-old child what a blockchain actually was. And he took a skewer and took pieces of paper and wrote stuff on the piece of paper, like a 1, a 0, or words or pictures or whatever, and then they put them on the skewer one after another. So that is basically the chain. The chain also has, important to know, a timestamp, and it shows the point of origin on the chain. So that's pretty much, say, this little bit in the back here, which then is the timestamp and the origin. What it's also is, it's the distributed ledger. And the distributed ledger now is a whole range of shash kebabs. So if you want to look at these little chains, they all now sit on multiple nodes. And within these multiple nodes, we have keys that then allow people to access information. There is a public key and there's a private key. Now the public key, for example, gives everyone access to everything that is being open, that can be opened with the public key. And then you have certain sets of information that you do not want some people to see, and then you can apply a private key. So the private key would, for example, be applied if you had a private-public chain hybrid, where you then would use the private key to, for example, open up medical records or information that's sensitive, such as this. So that's a public key versus private key, and then it's immutable. And the concept of immutability is a bit boring, but I ask you kindly to stick with me for a second here. So if you use a hash calculator like the Xobin.com hash calculator that sits on Xobin.com, the SHA-256, which you can go to and then look at, you can hash basically any kind of information. So if you were to take my name, which is Florian Krueger, you'd get this OC2A947 and so on and so forth, and that's a hash. Now, you cannot check it. You cannot change it. There's no way how you can now make a Florian Krueger or a Flo Krueger out of this by just leaving away a few numbers. That doesn't work. But what it does do, and what it also doesn't do, is very important to understand, is that you can't reverse engineer it. So if you get this hash, you can't put it into another calculator that then gives you a certain value, as in the name of the individual, for example, or the information stored within the hash. That's why it's secure. What you can do, though, is if you, for example, want to validate that it is Florian Krueger who sent you that information, then you can take this hash, then you can take the name, put it in a similar hash calculator, calculate the hash, and then compare the two hashes. And if the two hashes are identical, well, then you have validated the fact that the person is who he or she claims to be. So that's important because it's at the foundation of the chain, because all the various components or the various blocks are hashed. So then there are special nodes, and the special nodes are important in a distributed ledger because some nodes actually need to be able to do something. So to do something means they need to validate information, for example, validate the hashes. They need to find keys, find new blocks by mining. They can reach consensus about a certain amount, about a certain approach, about an identity or something like this. And they're incentivized through economical incentive. So they're incentivized by, for example, then being able to monetize for their efforts, which leads to entire server farms being set up in places of cheap labor and cheap energy, such as China, where entire server farms, entire data centers do nothing else than mining. And then you have a few development tools. Now the development tools are really at the core of it and are the reason why blockchain works. Smart contracts are at the very heart of it, and smart contracts aren't such an old thing. Smart contracts are actually rather new. Smart contracts have been first introduced by Ethereum and then have been adopted by other distributed ledger technologies, and then also now gradually making their way into the more traditional blockchain versions. So distributed ledger, just to clarify, and I missed this at the beginning, I'm sorry, distributed ledger technologies is basically everything. Blockchain is a distributed ledger technology, but it's not the only distributed ledger technology. Theoretically, you can also create your own by just setting up a distributed ledger. So smart contracts are at the very heart of it because they basically automate certain transactions. So for example, if you were to buy an IP asset, if you were to buy, say, any kind of information, you could do this completely automated without human interaction through smart contracts. And it's basically two sides with what-if clauses, and these what-if clauses, if they meet, if they are met, then algorithmically exchange the currency or the cryptocurrency for the smart contract and for the delivery of the IP. So this is a way to disintermediate and disintermediate massively. For example, what you can do is you can, as we did for a client in the oil and gas space, take bank guarantees and just put them on the chain, apply a smart contract to bank guarantees, and then have both parties transact fully automatically, and therefore then reduce the transaction time from several days, typically 3 to 4 days, to literally nanoseconds, and have no more human interaction. So smart contracts are at the very heart of it. The problem with smart contracts, as you can imagine, is that smart contracts are supposed to emulate or simulate real-world contracts. Now, there's a whole big argument around who actually monitors and who then later on decides whether a smart contract was valid or not. Currently, courts of law certainly aren't equipped to analyze this and to actually decide whether a smart contract has been fulfilled or not, or if some coding error happened, whether actually the coding error was instrumental to some severe consequences or not. So this is, despite the fact that it's super high automated and incredibly comfortable to use, it is still a little bit of a gray area, and therefore highly recommendable that you start using them in a lab environment first. In general, we see lots of labs, lots of pilots, lots of proof of concepts currently pop up, but the production for all of these will not happen much before next year. And then there is the private and proprietary chains component. So you can basically create a separate version of a chain and make it accessible only to a limited amount of people. You can limit this by, for example, putting it in one cloud instance, in one on one server, or on multiple servers which sit in one data center where only one company has access to, or you can just use a virtual private chain. And then you have all these applications that are currently coming up and being developed. So on Ethereum, for example, which is one of the chains that we'll be introducing in a second, we have currently approximately 4,000 different applications that have been developed that provide you with all sort of different options. So applications would then be, for example, the bank guarantee, which I just referred to, would be one of the applications that would sit on top of the chain. Important to note that you currently have about 100,000 people working at Ethereum as developers, pretty much full-time, which means that we can see a dramatic rise of additional applications in the not too distant future. So let's talk a little bit about use cases, because there are a few use cases that make sense. I already introduced the bank guarantee one, but then there's, of course, settlements, any kinds of settlements. There's claims processing. There's a whole area of trade finance. There are international payments, and there's the whole compliance, AML, KYC area. So if you look at all of these various use cases, then they are particularly good because they typically tend to be very labor intensive. That means that there's people involved, there's processing time involved, there is manual interaction involved, there's most of the time some paper documents that then need to be digitized later on and validated, and there's automatically, because of this, a whole range of possible shortcomings and a whole range of possible errors included in these old school processes in these areas. And since they're rather complex, they kind of make sense to be replaced by an automated system. So international payments, just as one example, are currently being charged to end customers by the Western unions of this world at an average rate of, I'd say, 10 to 12% per remittance. And that is certainly something that can be reduced to, I would say, somewhere in the 0.5 to 1% space, which would have a huge positive impact on everyone that needs to send money overseas to support his families. So let's talk a little bit about cryptocurrencies, and I said in the beginning that Bitcoin is not blockchain and blockchain is not Bitcoin. So to just lay the ground rules, we have to talk about a digital currency first. So digital currency could be something that I could invent, such as one flow coin. If I just say now I produce a flow coin and I put it on an email, it's digital, I send it to you, that means I have a digital currency. Now, if you're crazy enough to accept this and take it to the baker, then we have established a digital currency that has a value. If I'm saying I'm only going to produce one flow coin per week, and in order to see me, you need to pay me one flow coin, but basically you can only see me once a week, but you want to see me twice a week, I would increase the demand for a limited supply and therefore would increase the value of the flow coin and make it tradable. If I hash the flow coin, it would become a cryptocurrency. So remember the hashing bit that we talked about before, that I talked about before. If that happens now to one flow coin, then we have a digital cryptocurrency. And if I send it to distributed ledgers and keep a timestamp and uniqueness as well as provenance, then we'd have a cryptocurrency on the blockchain. So that's the digital currency example. Now, this is a real alternative, or also an alternative to an alternative to fiat currencies, a digital currency, and it's using a decentralized digital control mechanism. Now, what is important, like I just gave you the example with the flow coin, is the whole idea about limiting supply to be able to increase demand and to be able to raise the price over time. Now, the riddle that has been created to limit the supply is pretty much trying to emulate the complexity in terms of effort and energy of the effort of gold mining. It's been based on the principle of gold mining, and that's why these nodes that we talked about earlier, that I talked about earlier, are called miners. Now, examples for cryptocurrencies, digital cryptocurrencies on the chain are the ones that you know. Bitcoin, Ether, they're pretty well known. And then there's a whole range of others where you can pay on the darknet, which you can use for financial transactions only, etc., etc. It's important to know that one of the reasons for this raise here that you've seen, that I showed you a little earlier on in June, is twofold. Number one, we had plenty of ICOs, of initial coin offerings, where people were trying to make money, raise money by actually raising funds by issuing a cryptocurrency. Now, as you've seen, a digital cryptocurrency created, this is not a very difficult endeavor. Even if you have to put it on a chain, if you have to use Ethereum, for example, as a basis, it's not very difficult. So it's easily done. Now, if plenty of people start to do ICOs, initial coin offerings, obviously, with the supply and demand mechanism, the supply is limited and the demand is increased, and therefore then on trading platforms like eToro and others, Coinbase, the value goes up. Now, that was one of the reasons why it went up. The other reason why it went up was because it was used by, well, some of the folks that had held Bitcoins to wash their money, to launder their money, to launder their Bitcoin. The reason for that is that Bitcoin stores the information about the origins, but at the moment where you trade it into Ether on an exchange, that origin is wiped clean, and the only thing that's stored on the new chain is the information where you bought it at what point in time. That's one way of laundering Bitcoins, and that's part of the reason, and I think it's probably the bigger part than even the ICOs, why this has taken off so bigly. So what are the main companies behind the technologies, and what are the disruptive ideas in that space? Well, just so we talked briefly about them, touched briefly about them, we got Ethereum as a development platform, and as I said initially, we have approximately 100,000 people working and developing on Ethereum. We got approximately, and these are really rough approximations because we don't know for sure, somewhere between 10 and 15,000 people working on Hyperledger. We got the well-established blockchain, which is still being developed further. And then we have service providers such as Coinbase, we have real-time settlement, we have blockchain cryptocurrency services. Then we've got R3, which has made the news quite a bit because they collected quite large amount of money from various financial institutions around the globe to establish a distributed ledger technology, which they would argue is not a blockchain because it uses different mechanisms in a simplified fashion, which has seen quite some traction. But R3, for example, only has a few hundred, if that many, developers. Then you have applications such as Everledger, and of course, we'd like to think that we're also playing a case there because we're also developing applications such as, for example, the bank guarantee one, or some around KYC and ML KYC. So what does the future look like? You've heard about all these things. You heard about self-driving cars. In self-driving cars, you would automatically be able, if you put that information on a chain, to completely and perfectly well track the information, where they're coming from, what they've been doing. So it's immutable, it can't be changed, it can be traced, it's 100% secure, which means self-driving cars themselves lend themselves to, with their information, to be put on the chain. You have the possibility to now create programmable money. So you can have wallets, you can have permissions, you put that on cryptocurrencies, and therefore then make the money do what you want it to do. And since you're basically talking about a marriage between a virtual and a physical world, you can do this for many other things as well. You can do this for energy, you can do this for anything, and not just a thing. So what used to be the Internet of Things is now probably the Internet of Everything, because you're putting little stickers on stuff and have them NFC enabled. Now, all of that does you no good if you don't use something like a blockchain or a DLT to actually store the information securely and then automate as much as you can, which gets you to the part of the industrial automation. And we believe that the biggest opportunity for the blockchain will be around identity and personal data, which means that, in our opinion, in 10 years' time, everybody will be able to manage his or her own data set and will be able to open up or close the tap for information flow from one's own identity and data set to then potentially commercialize, if so desired, oneself and not the Facebook or the LinkedIns anymore. So there would be a further step in disintermediation, which might go all the way to actually owning the data oneself, not even anymore. So lots of change, lots of interesting things. We think that there is a very big chance that the database technology called blockchain or distributed ledger technology will remain as a very important cornerstone of any business in the future. It's currently gotten its biggest adoption in points, like I said, where you marry the virtual with the physical world, but it will replace currency over time. It will be used as a new currency with cryptocurrencies, and it will basically automate a whole range of applications. Disintermediating along the way, and also, and that's one of the risks, shrinking markets because of its widespread application. Now, if you have a whole bunch of people that you don't need anymore, then you can keep them around till they reach retirement, but what happens to the new workforce? So that is a risk that we have to face as a society, but this is where it's going to go. So this is a little bit about blockchain, where we see it going, and a simple, yet we hope rather complete information set on the trends and the components that constitute blockchain, and a little bit introduction. So if you want to learn more, please reach out to me, reach out to us at florian.krueger@fintricity.com. Go to our website. You can download this webinar in a different form, maybe also in this version, but you can have the slides if you like. Just let us know, and we're happy to share the knowledge with you. So, are there any questions? Oh my God, I must have talked too much. So there's no question right now. Let's wait another few seconds, but I think that was probably a lot of information. So please follow up with us individually. Ask us any question you like, and we are more than happy to explore and explain a little bit more in detail. All right. Well, I don't see any more questions come in, so thank you very much for your attention. Thank you for your time, and I hope we'll be in touch in the not too distant future. Thank you.